So let's say these are what LAN is user. So these LAN user can communicate with these LAN user by default or not. Here I am running RIP routing protocols, and we had already discussed the RIP. Here I am running EIGRP.
Yes, required.
Where you need to configure redistribution, brother? On which router? On which
Router
router?
3.
Router 3. Why? Because router 3 is connected with multiple routing. Router 3 is connected with multiple routing domain. Like here routing domain you can see is RIP. Here routing domain you can see is OSPF process 1. Here routing domain is EIGRP S number 1000. And by default the prefixes of EIGRP cannot enter in RIP domain, or RIP prefixes cannot enter in EIGRP domain. In the same way, EIGRP prefixes will not enter in OSPF domain, OSPF prefixes will not enter in EIGRP domain, RIP prefixes will not enter in OSPF domain, and OSPF prefixes will not enter in RIP domain. Yes or no? So guys, if I will talk about the routing table of R3 over here, so R3 will have these network as well, means 10 prefixes, these all prefix means 50 prefixes, let's say, and these all prefixes 70 prefixes. Router 3 will have these all prefixes, right? Like 10.1.1.0 to 10.1.5.0, 50.1.1.0 to 50.1.5.0, and 70.1.1.0 to 70.1.5.0. Yes or no? Yes, definitely. Inside the RIP routing table, these prefixes will be there. Inside the OSPF routing table, these prefixes will be there, and inside the EIGRP routing table, these prefixes will be there on router number 3. Okay, so by default router 1 or router 2, any other these routers will not learn 70 prefix and 50 prefix. In the same way, RIP domain means RIP protocol routers like router 5, router 4 will not learn OSPF prefix and EIGRP prefix. All the prefixes of OSPF and EIGRP will be not there inside the routing table of router belongs to RIP domain. Why? The reason is, see, when router 1 will send these network information to router 2, it will send one update message. And router send this update message to their neighbor. So their neighbor is router 3. It will send the update message to router 3. Right? Now router 3 don't have any neighbor, EIGRP neighbor with router 4 and router 6. So it will not forward the update message to these router. So these prefixes will be inside the routing table of router 1, 2 and 3 only. In the same way, RIP will share their update to router 4, router 5 will share router 4, router 4 will share with router 3. Router 7 will share OSPF database to router 6, and then router 6 will forward it to router 3. So here routing table of EIGRP is separate, routing table of RIP is separate, and routing table of OSPF is also separate. Yes or no? So on this router, what we can do for the communication between inter routing domain, communication between inter routing domain. Whenever we need communication between inter domain routing, then we need to perform redistribution. Redistribution means we will redistribute all prefixes of RIP in EIGRP. We are on that router which has both information, the information of RIP and information of EIGRP, like router 3. So on router number 3, we need to redistribute all prefixes of RIP in EIGRP domain, all prefixes of EIGRP into RIP domain. In the same way, all prefixes of EIGRP in OSPF domain also, all prefixes of OSPF in EIGRP domain, and all prefixes of RIP in OSPF domain, and all prefixes of OSPF in RIP domain. Okay, so first what we will do, we will perform redistribution over here. So router 1 will get these prefixes and these prefixes with what AD value? What will be the AD value for 50.1.1.0/24 network on router number 1? What will be the AD value, guys, for this network?
120.
Not 120. EIGRP uses two types of metric. One is internal and one is
70,
external. Yes, 70,
70 and no, no, 90 and 170.
90 and 170. So here AD
Ni-
value will be 170. EIGRP external. Right? So we will understand now if I need to filter those prefixes which belongs to, let's say, different domain from the RIP domain. I want to filter those prefixes or some prefixes from the RIP domain which we are receiving from the RIP domain. Actually, we need to identify the source protocol. This prefixes is coming from which source protocol, and on the basis of source protocol, we can apply filtering. So after redistribution, we will understand the filtering as well here. Okay, so these two topics are really very interesting. If your basic concept of routing is clear, then this class is going to be very interesting, very useful as well. Okay, and now we will not discuss what will be the AD value for these prefixes on router number 5 and how to, what we say, perform filtering or redistribution. This is not our concern. Our concern is try to understand the route filtering and redistribution of EIGRP only. How we will perform redistribution EIGRP. Guys, command is not like this: router EIGRP 100 and redistribute RIP. If you will run command like this, redistribute and RIP, what will happen? RIP protocol will redistribute it into EIGRP. But the metric calculation algorithm of RIP and EIGRP both are different. Yes or no? EIGRP router use K values like K1 and K3 to calculate metric. And in RIP, hop count is the metric. So here we need to manipulate metric as well. We have to tell if we are redistributing any other routing protocol in EIGRP, then you have to define K values. Okay, that means we are telling to router on this router to EIGRP actually please use this metric means K values for, like, let's say K1 is 1, K2, K3 is 1, K1 1, K3 1 to calculate metric. Okay, so first of all, guys, let me show you the configuration over here. Till now what I have configured on router number 1. First of all, I am going to check the IP configuration. I think I have already configured the IP address on all router. Exclude and assign. Yes, you can see I am running IP address on physical interface f0/0 12.1 and on I have created this loopback. Okay, so IP protocol, let me check, am I running? And yes, I am running one protocol EIGRP number 10 over here, and in this routing protocol I have run 0.0.0 command. That means EIGRP is enabled on all interface. Or if you want to verify that how many command I have run, so you can run command so run after that section and then router EIGRP. This is very important command for the troubleshooting. Okay, so I am going to check that how many command we have run in EIGRP. Only two: router EIGRP 10 and then network 0.0.0. Okay, no problem. Also IP EIGRP neighbor. So yes, you can see router 2 is neighbor, 12.1.1.2 is neighbor. So neighborship is also working fine between router 1 and router 2. Now let me check router 2 here. Directly I am going to check the routing table of EIGRP. So IP route EIGRP. So yes, you can see it is learning these prefixes, all loopbacks of router 1. That means neighborship is working fine and I have configured the IP address. So IP EIGRP neighbor, you can see two neighbor is there. Two neighbor are there, 12.1.1.1 and 23.1.1.3. Done. On router number 3, I am going to verify the configuration. Enable. So IP route EIGRP. So EIGRP is working fine here. Router 3 is also receiving these prefixes. So IP route RIP. So it is receiving prefixes from RIP domain as well. You can see 50.1.1.0 to 50.1.5.0. Okay, let me check the OSPF routing table. So IP root OSPF, and it is learning these prefixes from OSPF as well. Okay, so configuration is fine, guys. Here in this domain on router number 7, 6 and 3 F2/0, as I already told you that routing protocols work on the interface of router, not on the router. So on these interfaces I am running OSPF. On these interfaces of routers I am running RIP, and router 3 have roots of RIP, OSPF as well as EIGRP. But if you will check the routing table of R1, so IP route and let's say 50.1.1.0. So you can see network not available in the table. Why I am running command like this, guys? Because routing table, see, so IP route output is difficult, right? So directly I am going to check the IP route and 50 network is available or not. So no, this network is not available in table because we need to perform redistribution here. And for all internal prefixes, so IP route EIGRP, see, AD value is 90. This is the metric for 23.1.1.0 network. Done. Now I am going to perform redistribution on router number 3. So on router number 3, just I need to run very simple command, router EIGRP AS number 10. In EIGRP AS number 10, I am going to redistribute RIP. After that, as I told you that we need to define the K values, right, for the metric calculation. So here it is asking for the bandwidth. Bandwidth is, let's say, 1000 I am defining, and after that it is asking for delay, let's say 100. After that reliability, let's say 100, and then load 100, and then MTU 1500. Okay, so I have run this command, redistribute RIP, after that metric. So whenever RIP will redistribute any prefixes in EIGRP will use these K values to calculate metric. Done. After that it will so IP EIGRP topology. In EIGRP topology, you can see it have installed these prefixes, and it will start advertising with router 2, and router 2 will advertise it to router 1, and router 1 will learn this address. Now you can see for this address, when I am running command, so IP route 50.1.1.0, and this time you can see the output. Distance is 170. This is the metric by using K values which you have defined while redistribution. After that, type is external. This one is external prefix. After that, redistribution via EIGRP AS number 10, last update. Okay, so these are the information, and this is the next hop. So it have learned, so IP root EIGRP. So it have learned these prefixes. See, all external prefixes of RIP domain. Here also we have symbol is little bit difference in symbol. Here DX. DX means X. EX means external. DEX. After that, external prefix. EIGRP external 50.1.1.0. AD value 170, and this is the metric, and this is the next hop IP address. Done. It have received all prefixes of RIP, but now router 5 will not receive RIP prefixes. Let me show you. Router 5. So IP route, after that 10.1.1.0. You can see network node is table, and this router don't have 70 as well. 70.1.1.0. See, not EIGRP domain prefix, not OSPF domain prefixes. So here on router number 3, if you want to redistribute EIGRP prefixes as well in RIP, so you need to add one command over here on router number 3. This time I will redistribute in router RIP. and here I am going to say redistribute EIGRP. And the metric algorithm of RIP is different. So here also we need to say ES number 10 and then metric. And in metric here we need to define hop count. Let's say 5. So I am, see here on router number 3, I am redistributing EIGRP prefixes with metric what? 5. So what will be metric on router number 5? What will be metric on router number 5, guys?
Three
How 3?
interfaces.
If I will set metric 15 over here, so will R5 receive redistributed prefix? No, because R3 will advertise with metric 50, and as you know 15 hop away is not valid in RIP. So if here I am setting metric 5, so please calculate what will be the metric on router number 5, means hop count on router number 5. And on router number 5, now still this is not in table, I think. EIGRP 10 metric 5, okay, on router number 3. Router 5, this network is still, oh sorry, 10. Now you can see this network is in table and metric is 6. So because router is advertising it with metric 5, router 4 will advertise it with metric 6. If while redistribution, if I will say, let me say no over here, I'm removing this command and I am again running this command, and this time I am going to set metric, let's say 10. So on router number 5 metric will be, metric is
11.
10 plus 1. Router 4 is advertising with 11. Done. Why I'm telling you guys, because in upcoming day you will understand the filtering with metric. So you have to understand the metric manipulation as well, how to manipulate the metric. Okay, so now router 5 have also received all prefixes of EIGRP. Now from here you can ping 10.1.1.1 and source is 50.1.1.1. Now you can see I am able to ping the loopback on router number 1 from router number 5 loopback. That means end-to-end connectivity is there, right? Now OSPF, still router 1 don't have which root? IP root. So IP root 70.1.1.0. This network is not in table. So I need to advertise, redistribute OSPF as well in EIGRP. So again on router number 3, I'm going to say router EIGRP ES number 10 and redistribute OSPF process 1, and then if you will hit enter over here, right, what will happen, guys? We can run command like this also, but for that we need to define the default metric. What I can tell to this router, default metric. After that, okay, I am not here. We can define this one. Just wait, I will take you to this part as well. Okay, here I am in OSPF 1, but first I need to, okay, in EIGRP 10 I am redistributing OSPF 1. It is fine. So redistribute OSPF process 1. We need to verify this also once, that process 1 is running or something else. Let me run one command here. So IP protocol, yes, we are running OSPF process 1. After that, as you know, metric, because we have not set the default metric. I will show you how to set default metric as well. Here metric, let's say 1000. After that, delay 100, 100, 100, 1500. Done. I have redistribute OSPF prefixes in ESGRP. Now router 1 will have root for this network, but router don't have 70 prefixes. Why? Do so IP route OSPF. Yes, this router have root. So IP protocol, or yes, so IP protocol. EAGRP OSPF process 1 is running. Why guys? So IP EAGRP topology. In EAGRP topology table, are you able to see 70 prefix? 70.1.5.0, yes or no? Means this router have installed all 70 prefix in their topology table. So now please check the routing table 70.1.1.0, but it is not advertising with neighbor. Let me check it on router number 2. Router 2 have root or not. So IP root 70.1.1.0. No. Why router 1 is not advertising it? Can anyone tell me the reason? I am also finding the reason. So run section router EIGRP. Redistribute OSPF1 metric component, this one. Command is right. Let me do one thing. Router OSPF 1 and redistribute EIGRP is number 10, and here we need to say subnets. Let me check so router 7 is receiving 10 prefixes or not. So IP route 10.1.1.0. Yes, router 7 is receiving all prefixes of EIGRP. Yes, but router 1 is not receiving the OSPF prefixes. So IP route EIGRP 50 network, 70 network is there, 70.1.1.0. So we have problem with this output. So IP route 70.1.1.0. Here it's showing note in table, right? So this is problem of simulation software, guys. Okay, here we are able to see the prefixes of OSPF. Done. Now I can ping 70.1.1.1 also, and source is 10.1.1.1. Okay, so IP route OSPF, here like this you cannot check any prefixes. Okay, so all prefixes are known by EIGRP. So IP route EIGRP. This is EIGRP routing table. In EIGRP routing table you can see these prefixes are external prefixes, right? So here, can anyone tell me, is there anything guys through which we can differentiate that these are RIP prefix and these are OSPF prefix? Can anyone identify by looking the routing table that these are the prefixes of RIP and these are the prefixes of EIGRP? Yes, Rohit. Hello, Rohit.
By looking at the like a AD value 170, 90.
No. All external prefixes have same AD value 170. All external prefixes have same AD value, brother. Rohit, is redistribution clear to you? how to perform
Sir,
redistribution.
can you explain one more time the whole topology, the scenario, sir?
Why you have not got, brother?
Uh, Before going to the like a configuration, sir. One more time, explain it, please.
Configuration part.
Not configuration, but like a overview over the topology, sir.
Okay, 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 okay.
Overview over the
Okay, okay, definitely. Nirav, are you able to see any, thing which can differentiate EIGRP, oh sorry, RIP prefix and OSPF prefix?
Sir,
We have defined same K value while redistributing RIP
yeah,
and OSPF, so that's why metric is
same.
same.
So we cannot
Yes.
distinguish which is which one actually.
Here we cannot differentiate the source protocol. Okay, let me show you the topology table. So IP, EIGRP topology. This is the topology table. And this is like external prefix, yes or no? And this is also like external prefix 70, this one. Here, are you able to differentiate? Okay, guys, first of all, let me give you one overview of this topology again, as Rohit said. Okay, so see, in this topology, actually, we have three routing domain, means EIGRP routing domain, RIP routing domain, and OSPF process one domain. See, we can run multiple process of EIGRP and OSPF. That's why we have AS number and here OSPF process ID, right, to identify the process. So routing domain is actually EIGRPS number 10. This is routing domain of OSPF process 1 and this is routing domain of RIP. By default, prefixes of each routing domain will travel inside the boundary. Like RIP prefixes can travel in RIP domain only, EIGRP prefixes can travel in EIGRP domain only, and OSPF1 can travel in OSPF domain 1 only, right? Means, and router 3 is connected with all domain. So router 3 will have information of all domain. Yes or no? Rohit.
yes, sir.
Router 3 will have information of all domains. So here to router 3 we can tell that these are the prefixes of RIP. Please redistribute it. Please, allow it in EIGRP as number 10 domain. And after redistribution, actually it will start sending one update message. It will send one update message. In that update message, it will send K values and these prefixes, all prefixes from the RIP database. It will copy all prefixes of RIP in the update. It will send one update message. In that update, it will put all the prefixes of RIP domain. When you are redistributing OSPF, in the update, again router is sending one update message, EIGRP update message, and this time it will include all prefixes of OSPF from OSPF database. Okay, so this is actually redistribution. When we are redistributing EIGRP into RIP, so RIP is also generating one update message. In that update message, it will include all the prefixes of EIGRP, because router 3 is the router which have information of all domain. So it will copy all prefixes from EIGRP topology table and it will send one update message to router 4. In the update message, it will send metric which you have defined while redistribution. In the same way, when we are advertising or redistributing these prefixes in OSPF domain, it will copy all prefixes from EIGRP and it will send one database to router 6. In OSPF router exchange database, we will discuss when we will start OSPF. So this is what redistribution, where redistribution is required and how to configure it. Okay, Rohit?
Yes, sir.
And on router number 1 we are able to see now router 1 have all prefixes of RIP domain and OSPF domain. Now I want to differentiate the prefixes, like 70 prefixes belongs to OSPF and 50 prefixes belongs to RIP. We know this, but let me check router 1 know this or not. So in topology table like this, when I am running command show IP AGRP topology, we don't have any information through that we can differentiate it. Topology table, and if you will put question mark over here, so let me check. Here we have one option of detail link. So in detail link also you can see this entry and this entry, no difference. Here we have one thing called this. Okay, leave it for now. So IP route 70.1.1.0 255.255.255.0. Okay, here we have distance matrix type redistributed into AGRP10 update from A. Here also we are not able to see any difference. Means let's say on router number 1 I want to filter the prefixes which is coming from RIP domain. What I want to filter prefixes which is coming from RIP domain. Here let me run one more command. So IP EAGRP topology and 70.1.1.0. When I am running this command, entry not in table, and let me run 50. Okay, when I am running this command, guys, see the output.
Sir, external protocol is RIP. Say last second line.
Yes. External protocol is RIP. Here we can, identify the external protocol by running this command. So IP EAGRP topology, and let me run for 70 as well. For 70, why it's not showing in table? This is problem of this software, I think. Because 70 prefixes is there. So IP route EAGRP. Oh, yes, 70 prefix is there. Okay. So by running this command, so IP EAGRP topology, and after that network ID and subnet mask, we can identify the external protocol. We can identify external protocol OSPF as well, but don't know why we are not getting the output on router number 1. Okay. Let me run one more time. So IP EAGRP topology and 70.1.1. No, it's saying not in table. It is not in table. Let me type 2 over here. Maybe it worked. No, it's not working. So IP route EAGRP 70.1.1.0. Yes, it's perfect. Okay. So by running this command, we can check the source protocol as well, right? But through source protocol, we will understand filtering later. Now try to understand the scenario. First scenario is I don't want to, actually I want to differentiate, you can say, the prefixes of different routing domain like EAGRP and OSPF. So while redistribution, what we can do, we can add tag number. So whenever we will redistribute prefixes from RIP to EIGRP, I will add one tag number of, let's say, 10. So all the prefixes who will have tag number 10, we will identify that, okay, this is prefix of RIP. Now let's say I want to apply filtering on that, I will decide later. But on router number 1, these prefixes of RIP will be known for me with tag number 10. And while redistributing OSPF in EIGRP, I will add, let's say, tag number 20. So all the prefixes which will have tag number 10, those are prefix of RIP. All the prefixes who have tag number 20 are OSPF process 1 prefixes. Yes or no? Okay. So to add tag, just I need to do one thing. On router number 3, configuration is very simple, guys. Just try to understand. And you guys need to practice only again and again. Okay. Here I will create one route map. Route map. After that, name of route map is, let's say, RIP underscore tag. This is the name of my route map. After that, statement permit. Just I have created one, and here I will set the tag number, set tag number 10. So in last class we had discussed the one use of route map, how to filter prefixes in EIGRP with route map. On iOS, command was not working, but configuration was correct. So in this video also we will understand the route filtering as well with the help of route map. And here now I am using route map just to add one tag number. Done. I have add one tag number only. I have used route map to add one tag. And now router EIGRP is number 10. From here I am going to remove the previous entry, or let me check that this command is directly working or not. Redistribute. After that we are redistributing RIP. And before running this command, you know, we can define a default metric in EIGRP. Okay, first of all, let me remove the entry RIP. After that, to metric and 1000, or let me run like this, not working. 1000, 100, 100, 100, 1500. I have removed, so let me say no. I have removed the previous redistribution command from here. And now this time I am going to set one default metric over here. What we can set? A default metric. Simply we need to say, I think, so default and default metric, and after that weight. No, this is not the command. Metric weight 0. After that K1 1000. Okay, this is not weight. Okay, leave, guys. Command, I don't know the command exact command. What is the command? So redistribute RIP. After that metric 1000, 100, 100, 100 and 1500 byte MTU. And after that you have option of route map. Here I can use route map. What is the name of your route map, guys? RIP underscore tag. Done. After that, if you will put question mark, so we don't have any more configuration. Hit enter. Okay, and now on router number 1 I am going to show you the topology table. So IP EIGRP, so IP EIGRP topology. See all the prefixes like prefix 50.1.5.0 tag is 10. Yes or no? So IP route EIGRP. Here we are not able to see any tag, but in topology table we are able to see the tag. So now we can identify this is like this is the prefix of RIP. This is a prefix of RIP. Now I want to check the prefixes of RIP. So IP route, and after that we can say what? We can say, let's say include tag is 10. See, this is the topology table of how easy it is to check the prefixes which is coming from RIP domain. Yes or no? Now I can decide what I need to do with these prefixes. So first, let's say in the topology table we have thousands of prefixes or we have lakhs of prefixes, right? Lots of prefixes from other routing protocols like BGP, OSPF. So this is first way to differentiate the prefixes in EIGRP. We are discussing in EIGRP everything only now, right? When we will discuss OSPF, we will discuss again. Okay. So while redistribution, I have add one tag number. Now I am going to add one more tag for OSPF prefixes. Yes or no? So again on router number 3, I'm going to say first no redistribute OSPF process 1 and then metric done. I have removed the redistribution command. Again I am going to create one route map. After that, name of your route map. So let's say OSPF underscore tag. This is name of my route map, and again we will say what? Permit. Done. And here we need to set tag 20. Okay, now exit router EIGRP S number 10 redistribute OSPF process 1 and metric 1000, 100, 100, 100 and 1500. Done. Oh, sorry, no. And after that metric question mark. So we have one option of route map. Here I am going to call route map. Which route map? OSPF underscore tag. That's it. Only I need to run this command. On router number 1, again I am going to verify. So IP EIGRP topology. In topology table, see the 70s prefixes. Tag is 10. Tag is 20. Right? So now if I want to find the OSPF prefixes, what I will say here? Tag is 10. So these are prefixes which router 1 is learning through OSPF. Okay, and here if I will say 10, so these are prefixes of RIP domain. So now we can easily differentiate the prefixes. Okay, so till here any doubt to anybody? Till here guys everything is clear to everyone? Hello? Till here can you configure these things and can you explain these things, how redistribution works, and while redistribution, how we can add the tag number, and what is the benefit of tag number. We are going to understand more benefit of tag number as well later. So this is just overview. Okay, about the tag number. This is very simple. How we can add tag number while redistribution in EIGRP.
Sir, can we can only use numeric value for tag, or can we use any
No,
word?
only numeric value, brother,
Okay.
not name.
Okay.
Or what you can do, let me do one thing now. On router, go to config T. What you can configure in route map, that will be applicable over here. Route map, and let's say route map ABC permit set tag and put question mark. Decimal dotted value also you can define. Okay,
Oh,
Nidhav?
okay. Only two types of value you can define. Okay.
Yes. So actually we are adding tag in route map, and I am calling that route map while redistribution. This is the concept of EIGRP only.
Yes.
Okay. Now guys, my requirement can be, like in RIP domain, there are some prefixes, or in OSPF domain there are some prefixes. These three prefixes are of, let's say, sales department, and these two prefixes are of, let's say, HR department. Okay, and on router number 1 we need to differentiate the prefixes of sales department and HR department. So what we need to do, we need to add one tag number for these three prefixes and one tag number for these three prefixes. Yes or no?
Yes, sir.
Here, while redistribution, I want to differentiate two department in a single routing domain. Yes or no? So this can be also possible in EIGRP, okay, and in other routing protocol as well. So what I will do for this, on router number 3, first of all I am going to remove this entry, this redistribution.
On router number 3, sir, we also need to do summarization, I guess.
Summarization is not required, brother.
Okay.
See, I have removed this entry. Now here actually I need to differentiate the traffic, so I have to make interesting traffic by using ACL or prefix list or route map, doesn't matter. You have to define the interesting traffic. So I am going to create the access control list. Let's say access control list number is 1 and permit 70.1.0.0.0.2.3.255. This is the summary address of upper 3 network, right? Am I right, guys?
Yes, sir.
So I am going to define this. I have created this access control list. In this access control list, I have defined 3 upper network, all network of sales department. Let's say there are thousands of prefixes, so I will define thousands of prefixes over here in access control list. After that, I need to create one more access control list, let's say 2, and then again permit, and this time the summary address of lower 2 network 70.1.4.0. This will be the summary address, right? 0.0.3.255. I have defined both interesting traffic, one in access control list 1 and one in access control list 2. Now I am going to use route map. After that, name of your route map. Let's say RIP underscore tag again. I'm using name like this because in real time also whenever I need to configure these things I use name like this only. Okay, so that's why I'm using, because in real time you will see multiple route map on router, right? So name should be very clear. Route map, after that rip tag, then permit, and if you want to define the sequence number you can define sequence number, let's say 10. Here I am going to say first match IP address from list number 1. I have tell to route map, I have created one route map, rip tag. In that route map I have defined one entry that match IP address from list 1, and in list 1 I have defined upper 3 network, all network of cell department, right? And after that I am going to say set tag, let's say 101 for cell department. Then I have add the tag number. Now exit. Again I need to create one more route map, as you know, with higher sequence number. Route map name is rip underscore tag permit sequence number 20 and match IP address from which list? From list number 2. This route map will match IP from list 2, and here I am going to say set tag 102, let's say, for HR department. That's it. I am going to call this route map while redistribution. What I did, I create one route map. In that route map I create two route map. In first route map with sequence number 10 I have defined the match IP address from the list number 1, and if match will occur then set the tag 101. Done. I did same for the other route map. Now I am going to call this route map while redistribution. Router ESGRP 10. After that redistribute OSPF process 1 and metric 1000, 100, 100, 100 and 1500. This is metric, and route map. After that rip underscore tag. Now let me take you to router number 1. On router number 1, what I am going to do, I am going to check the prefixes which is coming from OSPF in cell departments. So IP EIGRP topology. After that what will be the command, guys?
Pipe include tag is 101.
Include tag is 101. So these three prefixes you can see over here. These three prefixes have tag number 101 and the HR department 102. You can see these two prefixes have tag number 102. So this type of scenario is also required, and hope you can configure this. It is simple. Yes or no, Nirav?
Sir, but when you just give the command, it is showing slash 32 as a prefix. So it is a
Where?
exact host match.
Where?
Yeah, in this slash 32 it is showing. So it is particularly showing one single host, correct?
So
70.1.2.1.
so IP EIGRP topology. Wait. Not directly. I'm going to check the routing table. So IP route EIGRP. Which prefix? 70 is prefix.
Yes, sir. 70 prefix.
Slash 32. This is our wrong configuration. Somewhere I think I have configured something wrong. That's why it is getting all individual.
Yes, individual. Yes. That I
Or
was
no. You know what is happening? On when here I am running what? OSPF. Yes or no? And OSPF
Yes.
consider loopback interface as on slash 32.
Okay.
Network type is loopback. In OSPF you will understand. So OSPF is actually advertising 70.1.1.1. This is a concept of OSPF on loopback interface. Network type is by default loopback, and in loopback interface router OSPF router consider the prefixes slash with slash 32. 1/32. Okay.
So maybe for that reason only there it is not taking that
No, no,
command 70.1.1.0
yeah,
directly.
that is that was the reason exactly. That was actually I also confused that why I am not getting 70 prefix over here. This actually I didn't see there, right? Jo, here I am running networks on loopback interface and I am running OSPF. So on loopback interface network, OSPF consider network with /32. So that I also forget. That's why I was running command again and again.
Okay.
Sometime happening.
Yes.
Okay. So till here clear everything.
Yes.
Now guys, my requirement is in EIGRP domain, I don't want to receive the prefixes of cells. I don't want to receive, actually this router never need to forward traffic in sales department. That was the reason actually we want to separate the prefixes of cells. Now I want to filter these prefixes. On router number 1, sales prefixes means tag number 101. These prefixes I want to filter over here. On router number 1. So what I will do, on router number 1 this time I am going to configure one route map. Now it is very simple, you know, you can filter the prefixes with the help of tag number. Getting my point? It is very simple. Just you need to create one route map. After that, name of route map, let's say filter underscore rip underscore sales, like this. And here I need to define one more thing. Route map and then name deny. I'm going to create the route map with which statement here? Deny statement. And match. This time what I will match? Match tag number. What is the tag number of
101.
sales? 101. Here it will match tag number 100. Exit. Route map and name of route map was filter underscore rip underscore sales. This was the name. Yes. Permit sequence number 20. Here I am not going to match anything, so it will match all. After that, router EIGRP AS number 10. Distribute list, again I will call to distribute list. Distribute list, after that I am going to use route map over here. So route map and name of your route map is filter underscore rip underscore sales, and direction, let's say in. So IP EIGRP topology include tag is 101. Okay. Okay guys, I have filtered the sales prefix over here. You can see. So IP route 70.1.1.1. See 70.1.4.1. See. Got it?
Yes.
Got it guys, everyone? Okay, so this was the, okay, filtering on router number 1. Can I filter these prefixes on router number 3? Can I filter these prefixes on router number 3 while redistribution? Why I will filter on router number 1? I need to filter it on router number 3. So yes, I
Yes,
can
we
filter
can.
on router number 3 also. Just I will create one access control list. In that access control list, I will define the interesting traffic, all upper three traffic. Then I will create one route map. In that route map, I will match the IP address from the list. So it will match all three upper prefixes. Yes or no?
Yes.
And then I will set tag number.
Yeah, same configuration we have to do on R3.
Yes, exactly. You will understand, advanced filtering as well. But now you can filter any prefixes or any type of scenario of EIGRP by yourself. If till here, if your concept is clear, now you have control on traffic flow. This is actual traffic flow of EIGRP. Now we don't have anything in EIGRP, just we need to understand the default information propagate that you already know, that when we configure default route on edge router, we need to redistribute in EIGRP. So there are some more concept as well. We can discuss that also. With the help of tag number, with the route map, we can perform any task. Like if I want to receive these two are prefix of this department, this is this department, this is this department, filter that department prefix on router number 2, on router number 1, or router number 4, right? While redistribution as well, you can filter the prefixes. Okay, if I want to filter these all prefixes on router number 1, let's say, can I achieve this task with ACL, standard ACL? I want to filter these all prefix.
So by using standard, it will only use source. So yes,
Okay, I want to filter only upper 3 prefix. Can I achieve it with a standard ACL? Yes, that also I can. I can calculate the summary address
okay,
and I
yes,
will permit
summary, yeah,
that
summary
summary
only
address.
direct.
Yes. So yes, a standard ACL can do that also. Okay, if I want to filter those prefixes which is coming from a particular source, can I achieve this type of task with the help of a standard ACL?
Yes,
Here I
yes,
need to
that is.
define source. Not possible. Let's say router 3 is receiving some prefixes from router 4 and from router number 5, both belongs to, let's say, same routing domain, and I want to filter the prefixes which is coming from router 4 only, not to router 5. So here I need to match the source. Here I need to use extended ACL. Here extended ACL cannot help you to achieve your task, because in a standard ACL we cannot define source, brother. So any filtering you can perform by yourself if you have learned. If anyone have any confusion doubt in filtering of EIGRP, let me know. Now last topic is default information propagate. Guys, we have four way for default information propagate. propagation. We have total 4 way to propagate a default route. Default information means default route. One, as you know, IP.0.0.0, you have run the command, and after that you will run redistribute static. Redistribute static in AGRP AS number, let's say 10. You are running command redistribute static. Let's say on router number 1 have one default route. Let me configure one default route over here. IP route 0.0.0 0.0.0, and I am configuring this loop, this default route towards, let's say, loopback 1. So I cannot configure it towards, let's say, f0/0. (1/0). This interface is not active. Okay, I've configured one default route on router number 1. Now by default, definitely router 1 will not include this default route in their EIGRP table. It will not include this default route in their EIGRP table. This is the default behavior, even if you have configured the default route on router. Okay, so here you need to run command router EIGRP as number 10 and redistribute static. And then if you are advertising any other routing domain in EIGRP, you have to define the metric 100, 10, 10, 10, 1500, like this. After that, router 1 will start advertising one default route in EIGRP domain. After running this command, it will check the table. Whatever static route this router have, it will include all prefixes in EIGRP update in their topology table.
Sir, what is
But we have some,
what is the best use practice for this defining this metric value? Like, is there any best
here I
practice?
have one single command, brother. I have one single command. Command is default metric. And okay, let me.
No, I am asking these values that we are putting 100, 10, 10, 1500. So there must be some
No, these are random value.
yeah, that I got it, but there must be some best practice values in as per documentation or anywhere, like which are best, because by default I guess now the metric also depends on this what I can say.
Brother, these all things depends on your link only.
Yeah,
By
so that
default, by the way, it is going to use only this and this.
yes, 100 and
K1
yes,
and K3.
yes, K1 and K3 only.
So whatever your actual, bandwidth of interface is, calculate the percentage, and you should give 70% to here.
Okay,
70% bandwidth of your link.
okay.
Okay. So on router number 1, not 1, on router number, let's say 2. So IP route EIGRP. So this router have one default route, yes or no?
Yes.
Default route, AD value same, right? Who is advertising it? 12.1.1.1, right? Through 12.1.1.1. So router 1 have started advertising one default route. The second way is, this is the way which you already know. Okay, now let me tell you the 4 way. First, redistribute static default. Redistribute static default. Okay, this is the first way. Second way is summarization. Yes, summarization. After that, candidate date of candidate of default route, and then network 0.0.0.0. You can run this command also to redistribute default route in EAGRP. Yeah, this command will also work fine. Okay, after that, summarization. See how through summarization on router number 1, what I am going to do, I have removed this command. Done. I have removed this command, redistribute static and metric this. Okay, and again I am going to say redistribute, sorry, not redistribute, I am going to show the summarization method. Interface f0/0 IP summary address for EAGRP10, and here we will say 0.0.0 0.0.0.0. That's it. It will start advertising one default route from fast Ethernet 0/0. So which one is easy, guys? Which one is easy to redistribute these prefixes in EAGRP? Easy to configure.
Yes, sir, this summary, I guess.
Okay, summarization. Yes, definitely. If we will talk about the configuration perspective, so it is very easy. Okay, again I am going to remove this command. And then we have this command also. So I have removed this entry. Now you can see done. Router 2, I think, let me check the routing table of router 2 again. No, this router don't have no default route. Again, what I am going to do, I am going to run network command in EAGRP. Router EAGRP is number 10 and network 0.0.0.0. If I will run this command, then also you can check on router number 2. Soon it will receive. Network EAGRP is 10, network 0.0.0. Do so IP route. Default route should be available over here. So default route is available. Connected on. You know why it's not working here? Because on the same link, I am advertising summary route from F0/0. Right, and that default route is also towards fast Ethernet 0/0. It will never include that prefix in update, sorry, common prefixes or common segment in the update. So it is not including 0.0.0 here. That's why otherwise command is fine. This is the command. Network 0.0.0. Okay. And then we have last option, that is get a candidate of default route. Guys, in candidate of default route, what we will do, we will advertise one network, and through that network I will advertise, you will create one loopback on router. Let me create one loopback. Let's say interface loopback 10 and IP address is 192.168.10.1 255.255.255.0. Now I will advertise this loopback in EAGRP router EAGRP 10. I can advertise the existing loopback as well, but I have created the new loopback so that you can understand from the initial. Okay, after that I have configure one IP address there, and here I will run command IP, not here, I think it's in global config mode, IP default information default network. After that 192.168.10.1. This is the IP address na. Yes, that's it. Now router 1 will start advertising one default route with this network. Okay. On router number 2 you can not see, because here what we can do one thing. We can configure the default route on R3. Let's say I'm configuring one default route on R3. Enable config t IP route 0.0.0 0.0.0 f1/0 towards router 4. I have created the now router EIGRP is number 10, and here we don't have loopback now, so interface loopback 1 and IP address is 192.168.10.100.1. Done. Router EIGRP 10 network 192.168.10. Sorry, 100.1, or we can say 0. Done. After that IP default network 192.168.10.1. Sometime you will be not allowed to summarize by running network command or IP summary, so you need to use this method only. Okay, so now on router number 1 I'm going to check the routing table. Here I am going to simply say no IP route 0.0.0 0.0.0 and f0/0. So IP route in the routing table default route is available connected on loopback interface. Oh. This router is not receiving default route. Let me check on router number 2. So IP route, it is also not receiving R3. So IP route why it is not advertising default route. Ten dot 100.0. So route is available but default route is not available. So IP route, that network is reachable. So on router number 3 IP default network 192.168.100.1. Interface f0/0 shutdown and no shutdown. It should work. Configuration is right, guys. So IP route. Yes, router 1 is not receiving default route. Why? Don't know why R3 is not advertising it. But your configuration is perfect. R3 should advertise one default route. It is not advertising, but let me check the topology table of R3. So IP EIGRP topology. So guys, tomorrow we will start. Okay, it is not receiving the default route, but it should receive one default route. This is the last method of default information, default route propagation, or how to advertise a default route in EIGRP. Mostly we are using this command only. Okay, after that you can use summarization as well, and sometime you will be not allowed to run these two command and network 00 as well, network 0.0.0.0. Okay, so very commonly we are using these two method. So here we are ending EIGRP, and our next topic is OSPF. So please complete your lab guys, which I have shared with you of EIGRP. And I will share one more lab where you need to perform the summarization and path manipulation, these things. And Nirav, anything else?
Sir, I guess one topic I was checking that was related to stub. That day when you explained about that stub router, stub
Okay,
configuration. In that, I checked some other videos also. So they showed that when we configure this hub and spoke topology
okay,
using EIGRP, so basically, after configuring stub, it should not uh, particularly get any kind of query, correct?
correct.
So that part, uh, I need like if any briefing. And one more part they showed is regarding that, say for example, if we are using same topology, that hub and spoke topology which you showed. So in that,
Okay,
if the hub hub link is bombarded with all kind of traffic, so
okay,
what will happen? That it may become congested, okay, due to traffic.
okay,
So what they did was they removed that IP next hop command.
okay, definitely. IP next hop self.
Yeah, self, next hop self. And then
Hmm.
they showed that now what they will do is both the spoke router will directly ping each other via trace.
Yes.
He showed that via tracer. So these two things, just brief would be good.
Okay. Okay,
Other than
stub and the hub and spoke topology. So, but
yeah.
you have explained the very right. Everything will work like this only.
Yes, sir. But say for example, like in stub, same thing will happen in OSPF also, no?
Yes, same thing will happen in OSPF. You know, we have concept of network type. So in
Yes,
hub
yes,
and
yes.
spoke topology, we have a separate network that is point to multi-point.
Point to
So in
multi-point,
this
yes.
type of topology, we will learn that network type. Then behavior of OSPF will be different.
Change, yes, yes, yes. According to Cisco, there are 5 types of networks.
Yeah.
But
Now we have discussed how to deal with hub and spoke topology in EIGRP.
EAGR, okay.
In OSPF, we will discuss how to deal
Out.
with this type of topology in OSPF also.
Okay, okay. Yes, sir.
All filtering, path manipulation, everything we will discuss it. And after that, let's see, maybe we will discuss advanced BGP also in this class. So if you guys will available, right, to reply, then we will discuss, advanced BGP.
Okay, okay, sir. BGP is totally new for me. I have never touched
Oh,
BGP. Okay, okay, sir.
really? But BGP is very important protocol.
Yes, sir.
You know
BGP
this?
and OSPF both are very important outside.
Yeah, yeah, yeah. So it's a great opportunity then for you to learn BGP.
Yes, sir. Before that, I'll try and do some study.
Okay, okay. Yes.
Okay, okay.
Okay, then we'll meet tomorrow.
Tomorrow, sir,
Okay.
Saturday.
Tomorrow means Sunday.
Okay, okay.
And please share the configuration file, guys, because it is very important. Few people have
Okay.
some mistake in the command. I did not completed the task, so I will tell him personally. Okay.
Okay.
Okay, guys. Bye bye then for today. That's all for today.